So we only have two panelists today, but so hopefully the rest of you will just pitch in and we'll make just a free floating discussion. My own contributions here are just to stimulate this a little bit. So I just wanted to, let's just to start off the discussion, talking about moonshots is really talking about requirements, and this famous graph, which has been reproduced in different ways, was from the IMT 2020 vision, I guess was set now maybe about 10 years ago. And I just want to start up, and it sort of put three types of requirements, either in terms of throughput, latency, and connectivity in terms of number of devices, the latter one being related to energy requirements. My view from looking at this right now is that all these dimensions are pretty much technically feasible. The prototypes that are being done are pretty much meeting them right now, but it's a question, I think, of getting it down to cost and getting the coverage out. And maybe just to start either with our panelist or anyone else, where are we in terms of that, and also maybe what would be reasonable targets for what's next in terms of these parts?
Yeah, I think in the last couple of years, we've really just focused on one aspect of this, just the mmWave. And that's just the industry's been focused on that, especially on the millimeter wave side. And I mean, specifically on millimeter wave, mmWave was the clear target. And it's hard to imagine what kind of a role it would have in ultra low, high reliability, low latency part is fine, but the reliability part, there seems to be a place for it in industrial IoT. If we can get the cost down, but really it has just been mmWave. And on the mmWave front, if we had this conversation maybe 2 years ago, it probably didn't seem like it was that cost effective. It wasn't that clear, but now it's shown to be cost effective. Once the industry puts all the resources to it, it becomes cost effective. So I think So
you think it's just once it scales to the right volumes, you don't foresee there being a cost issue with building these devices?
Yeah,
at least on the smartphone
side. I foresee it. Yeah.
Michele, do you want to just quickly talk about on the networking, on the low latency part? Where are we now?
Yeah, well, I guess I wanted to make a comment that I think we've seen a lot of focus on the high rates, the millimeter wave, closing the link at these frequencies, showing that this is good and this works. I actually think we don't have a good understanding of how the network will work. I don't think there is enough work done. And, in a way, I'm a little uncomfortable with this focus on test beds, because I think we also need fundamentals. We need fundamental understanding. Being an academic, I'm all for that part, mostly. And I think the fundamental trade-offs that are there, I don't think they have been explored sufficiently. I wouldn't even be able to say if those trade-offs are just the same as we know from other networks, just with different parameters, or there is something fundamentally different. Coming from the networking side, just an example, the need for directionality. Ted made the point that directionality will solve the issue of the path loss, right? Because the antenna gain will compensate for the path loss. But then, when you look at it from a networking perspective, there is a delay issue, which is there. There is a mismatch between coverage in the data plane and the control plane, which will make these networks harder to manage. And so all these trade-offs, people are looking at the extreme broadband, the ultra-low latency, the energy issue, the coverage issue, but are we looking at these together as a multidimensional space where we need to find the good operating point or the good trade-offs, or the boundaries where we can or cannot go? All of this, I think, hasn't been done in this community. There are some people working on networks, and there are some contributions there, but I think much more is needed. And so we're happy with all this physical layer work and link budget and measurements, but really we need to go to the next level and show that these networks can work, can be managed. It's hard because experimentally you can't do much Simulation-wise, you can do more, but we discussed yesterday in the Bracket group, simulation has its own limitations, so that's another modeling issue that needs to be solved. So, if I look at it from a network perspective, nothing has been completely solved yet. And so I don't think it's a moonshot because, we're talking about the system we've been looking at for many years. But really, I don't think the progress in the networking area has been as significant as it should have been. And so I see that as a wide open area where we should really invest a lot of brain power. And also looking at fundamentals, analytical tools, maybe some simplified models that get insights to be complemented by these measurement and experimental platforms, certainly. But as a mostly academic community, I think we should try to provide what we're best in, right? Which is insight and understanding.
It's interesting. Maybe one way to think of Moonshot is, what would be the ultimate theorem that, like, if you think of, okay, like MIMO had the capacity formula, there's a single, expression that encapsulates the whole MIMO theory that was really revolutionary. And there are similar results in queuing theory and in network and TCP, but there's been really, maybe I'm wrong, but I don't think there's been a single or really significant theoretical result of that nature.
Some information theory approach where you include explicitly this flakiness of the channel, this extreme dynamics, or this inherent diversity you need to have, multi-connectivity and all that. Does that change fundamentally some of the theorems we know? Some of the Shannon type, maybe, but we don't really know. We haven't thought enough about that.
Okay.
And if I may add, let me see, on the
testbeds are. So I'm going to. You're saying, right, that hey, we need to do fundamentals. So I agree with you. And what I'm getting at is that we don't necessarily know, as you said, what is different here. So I think there's something very different here in terms of the characteristics that achieving this latency, low latency, is going to be challenging. And there's a lot of things in the air, and test beds, the hope is that, or the goal is that we actually build these test beds so that we can answer those questions in parallel, so that, you can have a theorem which may be irrelevant, right? Because it makes assumptions and you have a beautiful theorem, but it's useless. On the other hand, you could have a test bed which is useless too, because it doesn't allow you to answer meaningful questions. So it's somewhere in the middle. We want to join forces. Can't be this or the other. And industry, with all due respect to industry is going to go where they are going, right, where they can make the most money. And so they'll give one straight jacket after the other, which is not going to let us answer the fundamental questions necessarily, because they'll have a specific way of doing things which are cost effective at that time. So that's the goal here. Okay.
So on that note, one way to think about, I put this up because is it too early to be talking about, how would we want to change? So that, for example, there's this 100 megabit per second number on the mmWb, or the less than 1 millisecond latency. And I guess in different parts we've reached or not reached these. Is it too early to be thinking about what would be the numbers as a moonshot to go increase these? Or is this even the right way to be thinking about what is a moonshot, or the next step, at least, for the field?
Well, is it all about numbers?
I don't know. That's my question.
If this is about improving those numbers by an order of magnitude, we can agree that's a legitimate goal, or maybe it's not a legitimate goal. Maybe there's something different. I could certainly see increasing the data rate as something we may think of. Now, decreasing latency, I think you're going to hit some physics. Yeah. Because there's only so much distance you can cover with a small latency, and so at some point you're going to hit that. And so you either decide everything's going to be heavily decentralized, or you're just giving up, because that's not going to happen, right?
All right. The other. Oh, go ahead.
Yeah, I think that, so the data rate part, we can always increase it by just, right now we're talking 5 gigabit per second for a UE, but then you can always add more layer if you densify enough, and you can go up to 256 QAM or further, or do channel bonding across 28, 39. You can always increase it, but I think the fundamental issues will really just be trying to make this more robust and more stable. And Because when you come to data rate, even 5 gigabit per second, everyone loves it for PR, and everyone will put in the headline. But when you talk to any operator, they don't know what it's going to be used for.
Right.
They'll admit that there's no need for it until someone comes up with an application that requires it. So then they just throw VR there, because VR is the only application that is in the gigabit per second. But then, is there really a business case for VR in a public environment? Where are people going to walk around with a VR headset? I doubt that. So right now, I think the main focus really should be the stability and the lowering the power and making this more cost-effective before we start increasing data rates.
So what is, also put up here, so we've seen that, in a lab situation with kind of infinite resources, you can create these high data rates. And you're saying that the economies of scale will drive down the subscriber cost. But if we look at the network side, what's the cost barrier to delivering, even in the order of, say, 1,000 megabits per second throughput universally? Is that affordable right now from the operator's side to put in the network equipment? And what would it take in terms of research to get it, or development to get it those cost factors down?
Yeah, I think the small cells themselves have a cost issue, and it's really on the RF side. So there's really no cost-effective phased array right now for macro small cell stations, and that's where I think leveraging the UE side will help out quite a bit. So any development on the UE side where you're deploying millions of these devices, and if you can leverage that on the base station side, and that's going to be key. Then there's also the deployment part of course, of trying to bring backhaul to all these small cells, because you really have to densify enough so that you do have a robust deployment. And if you densify, then you have to run fiber or a wireless backhaul. But then there really is no appealing technology right now that, unless you go for the proprietary technology that allows you to get the wireless backhaul. So that's why I think the integrated access backhaul work is quite important to really have a cost-effective deployment.
Yeah. Another thing I was thinking is from network side, this protocol overhead, right? So, this 4G or 3G or 5G protocol stack, if you take a look, is very complex, especially this control signaling or PDCP, all these things. And also some of them inherited from this legacy phone network. So it's from network side, I don't know, for the 3GPP point of view, is that their roadmap, to all this GDP tunneling, all these things. So is there a way to simplify it, and make it, I guess they are trying to get more flat network, but so is there something to reduce this overhead, because this is related to the latency and also the cost, right? So from capacity point of view, you can always, and improve the physical layer, increase the capacity, and even you have some control overhead, probably you can compensate that. But from latency point of view, probably is more important, and to take a look at the stack, to see where we can simplify it to speed up the process.
Yeah, there are actually several dimensions to this. One is the device complexity, right? If you need to run a complex protocol, then you may need more resources, and on a cheap IoT node, you may want to relieve that complexity. So that's one thing. The latency, and I would add energy as well, dimension when you have these complex protocol stacks. This has been addressed. Clearly, it's a known problem for IoT, right? Because you send only a small piece of data, you have to exchange 20 times more messages in order to do that. So that's a problem which is being addressed. I'm directly aware of some work coming from Aalborg University on simplifying LTE for this machine-to-machine type, where they try to compress these handshakes, this exchange, back and forth of signaling messages by maybe combining functionality into the same message. So this is being addressed. And so, but that's clearly one way where we should go, especially in this machine-to-machine or IoT type of scenario. Now, another issue related to this, I would say, is about the network architecture, right? So not just the protocols, but the network architecture. So what is the network architecture going to be? And we face a lot of complexity in terms of heterogeneous nodes and traffic. We face a lot of issues about, at least in millimeter wave, for multi-connectivity, and so this comp type or maybe quick handover or multiple connection active at the same time type of issue. And even though 5G suggests an evolution of a cellular systems to a new cellular system, so does this have to be cellular? I mean, people are talking about no cells. Would that actually a question? If you do away with cells, right, whatever that means, is that simplifying the network architecture, or would that complicate the network management? Right.
So
yeah, here's
Parmesh Ramanathan from University of Wisconsin-Madison. So I'm not quite answering the thing, but yeah, part of it is if you're thinking of the moonshot, I think some of those things have to be on the table, right? Including whether we want to get rid of IP. I mean, I know various times over the years I've been in this thing for 30 years, and we have predicted the death knell of TCP or IP and those kinds of things, but we have never ever got there. But maybe this is the time for us to think through and make some fundamental changes to the networking stack, because it may not be feasible to get those low latencies, however lightweight we go. I mean, we have been working on those kinds of things for a long time, how to make it lightweight. And it's just not feasible. I mean, or we have not had any good breakthroughs on that thing, and that's why we are stuck with TCP and IP, right? So maybe we need a completely different network protocol stack completely.
Maybe just on the complexity issue. So the 3GPP, of course, has, in one sense, simplified it because they have the data plane separate from the component plane. That was already a case in 4G, and they partitioned it even more in 5G. And in terms of the network architecture, they've made it extremely configurable. So you can have the kind of standard, more centralized packet gateway structure, but also distributed gateway structures. And then with the network slicing and network functional virtualization in 5G, it's extremely configurable. But I guess there's two issues. We don't really know how this is all going to be used. It's almost like it's even worse than the Airlink, which has a million different options. In the network, there'll be even more. And the other part there is, there's another type of complexity, which is just this, if you try to, and we're going to probably hit this when we talk about the testbed development, if you actually have, there's a huge barrier to entry to implementing these protocols, even if theoretically when they're implemented, they're extremely fast. I mean, there's just thousands of pages of specs and aspects of these protocols, and that's another type of software complexity, which it's another whole issue. Maybe I transition. We can come back to these, or at least in the context of some use cases that might drive what we think about. Moonshots. So. If you look at, of course, there's a standard for everything in 3GPP. So if you look at 38.913, when they were envisioning for 5G, they list a number of use cases. Hotspots, connected cars, highways, all sorts of things. So I just want to go through a couple of these and wonder, how close we are to these, and whether any of these might define how we're going to direct research. So let's start off one that's come up in a lot of discussions about connected cars. So connected cars is, of course, connected to autonomous driving. Where are we now in this? And how is this driving 5G, and how will this drive requirements? And maybe instead of going to the panelists, I'm going to flip this over to Tomi, because I know he gave a talk about this at IEEE 5G forum, and maybe he can. I'm sorry to put you on the spot there, but sort of knowledgeable in the area.
Yes.
And you just introduce yourself.
Okay, Thompson Chalmers. So the question was, where are we today in connected
Yeah,
cars?
that's right. And how is this going to drive the use cases for 5G and what we should be doing in terms of wireless research in the next 5-10 years?
Yes, I think that there are different perspectives, different parts of the world, and academia and telecom industry and automotive industry, and inside the automotive industry there are also different views. But I see a moving trend towards connectivity of vehicles in the automotive players, away from ITS, DRSRC kind of connectivity towards network assisted. They start to see the value of it. So I personally think that there will be steps. They will start with DSRC kind of connectivity to implement the basic IT services, and then every vehicle will need cloud connectivity, and that will be more and more data. And when you have these modems, they will start to see the added value to harvest what I normally talk about, improved information horizons, because that's what the mobile network can add to the control systems for active safety assisted vehicles and towards fully autonomous. So we have a EU project called 5G Car in Europe.
What's it called?
5G Car.
5G car, okay.
So just Google on 5G Car and you will find the website. It's a 2-year project and we run 1 year now. And there are a lot of use cases there. And I would say the most advanced will be remote parking. So it's not. It should be an enabler for autonomous vehicles in massive scale. But personally, and the European industry seems to think that it's a little bit further away. It's what is the unplanned statement now. I have a 40 minutes presentation in my pocket.
Oh, okay. Well, sorry, put you on the spot there to give a quick summary.
But I think also, I was also in a panel at the UCNC a couple of weeks ago, this European conference for all EU projects, and my view there was that maybe you should split focus in the public space, regular cars driving in cities, with a mix of manual cars and pets and kids and bicycles and pedestrians that are blocked with headphones. It's quite complicated use case. So why not? So there maybe we should have. Maybe that's TED shows the hype curve. I think that is a hype curve problem. It will take 10, 20 years before we have it fully autonomous in a massive scale. But there are a lot of other use cases in professional contexts. Harbors, mining areas, building construction areas, factories for store warehouses, sure. automatic robot cars in warehouse, high-build warehouse storage. They can be fully autonomous. And there we really could play with controlled network assistance and learn what we can use 5G and beyond 5G for. And then we are ready to go massive scale in network assisted autonomous vehicles. That's my view.
Okay.
Can I add
millimeter wave will play a role. Just as a comment. In street canyons, I think millimeter wave have a good fit.
Yeah, you need to distinguish between connected cars and self-driving cars. There are two very different things, right? And was another IEEE event a few months ago, and someone from Berkeley made it very clear. Self-driving cars, totally autonomous, able to drive wherever and in any condition. That's going to be very far into the future. Now, connected cars are useful, but they're not by any means self-driving or anything like that. Now, the second aspect is that applications for connected cars, because cars can talk to each other or to a network, may be very different in terms of importance, in terms of requirements. Clearly, safety-related applications, typically short messages, low latency, high reliability, versus entertainment for your kids, so they don't bother you. That's a different thing. So where is 5G millimeter wave playing a role? Well, high data rates can help in both the entertainment, but also in some safety-related, like LiDAR images are very heavy, and so there is a role here for millimeter waves, I think. Although, how to make it work in a highly mobile and highly dynamic scenario is, of course, a challenge, right? So we're actually doing some work in this area and trying to find, what are the fundamental limits.
Yeah, I think the current EMBB for millimeter wave definitely solves the infotainment needs and the HD map needs, and it makes a lot of sense for a car. And then I agree that there's high mobility, but if you look at some ways like highway, New Jersey Turnpike, or some ways where they've already cut down all the trees, and it's a clear line of sight, and everything's very predictive. You can predict that the car is coming from there, and then next step it will be, you can track the cars fairly easily. It's a very predictive environment. But the problem really with the connected car in that use case is really that the car industry moves very slowly. And by the time they adopt something like that, it's almost unless there's some kind of a mandate, it's very hard for those things to happen immediately, right? Because the operators will not deploy base stations for that use case because the car manufacturers will move slowly. They'll focus more on the EV handsets, and it'll take a while before those two things converge, and that connected cars, there is infrastructure for connected cars on highways, unless there's a mandate by a government mandate, and then they, all the industries, join together.
What's the state of DSRC now? In terms of deployment. What's the state of DSRC in terms of deployment? Even that standard's been out for a number of years.
Some car manufacturers announced they will deploy DSRC in all their cars, maybe from some level up soon. And so that's happening. I don't know if it's mandated, but it is happening.
Akbar,
this panel is putting me to sleep. And so, so what, so for everything there's, so I've heard, that, hey, we need to do some more fundamental research. And then, for latency, yes, there'll be a physical problem, but let's classify where. So are there use cases? So I'm just trying to put some structure here. So latency, is it, Palmer said, well, we've been trying to make things lightweight for a long time, but TCP/IP, is it's embedded everywhere. Yeah, we're not going to replace that anytime soon unless we make a very darn important case. So what are the applications where latency is going to be an issue? And then we have to address the question, okay, physically, what are the limits? We can put radius in terms of, speed of light, and that'll give us the first thing, and then what kind of networks can be within it. So can we put some structure on the kind of research problems that we can address? And do we have enough information? And how does industry, industry, it seems like, there's just anti-robustness. So what is there something to collaborate, or is it lost cause? Seems like it's a lost cause. This is the fourth meeting on RCN, and NYU, you guys have a lot of the affiliates, but I don't know how much, your comment was yesterday, yeah, we listened to you guys initially, and then we went and did our own thing. So, what are we, can we, what is the role for collaboration here? And what, are there some problems that we can identify where we can, whether it's theoretical or whether it's, if it's end-to-end simulation tools that you're developing, what is keeping them from being predictive so that we can actually help address those fundamental questions, or maybe explore some from scratch protocols to move things forward? It seems like we are just, passing the buck to some other domain where, putting the blame somewhere else. So what are we willing to do to push this forward?
In terms of application domains, I mentioned two good candidates. One is automotive, right, where low latency is needed. Because
what you earlier said, there'll be some physical limits, right? So why is low latency limit needed, and what kind of information? And
if you look at safety-related applications in the automotive domain, where you mostly talk to your neighboring cars, which are very close, and so the physics limit goes down, then that may still be feasible. The second application scenario where I think this is going to be important, and the scenario itself is going to be important, is industrial IoT. Right? in everything that where you have a control or automate the process and tightly control things from a safety perspective, but also from an efficiency perspective, the timescales in those environments go down significantly. And so that's another area where low latency will be important. And again, it's a local environment, and so probably the latencies will be because of how you design your communication system, not because you have to travel 100 kilometers. Right?
Yeah. So what about those, different dimensions? I don't know which company has that, 5G different latency rate. What are maybe some of the pain points? Maybe we need to look at some extreme cases and use case and kind of look at where those applications would come in. This kind of thing, but there's another, I don't know, maybe Nokia had that where there's like different dimensions like latency, complexity, and things like that. Maybe that's what we focus on or some use case.
So one thing that maybe we need to investigate is, I mean, clearly in the back end, replacing TCP and IP is going to be much more challenging. But we may be able to now, because of the way it is, have the gateway in between that has a different network layer protocol for the last mile or the last hop and a different one on the network. I mean, IPv4, we kind of, it's death knell because of address space, we kind of solve by putting the NAT boxes all over the place, right? I mean, same way, I mean, now maybe it is a time to think of these other boxes that will do the gateway between two network protocols. Because for the AR, VR stuff, maybe it is just like local thing, and we could achieve the latency that is there, and only for these end-to-end applications that we need to go to IP and TCP, and maybe a network gateway that translates to these two protocols, maybe a solution that we have to go for to achieve both latency while retaining the legacy of TCP and IP in the back end. And then we need to investigate what would be a suitable network and transport protocol just at these UEs and just at the last half of the millimeter wave, or just basically more generally these high data rate wireless networks in general.
So can I intervene? So my comment here is we've done exactly what you're talking about in the millimeter wave specifically. So reconsider the proxy server solutions to maintain the TCP/IP semantics while designing something more cross-layer in the last hop. And we have some really good results. It's based on the simulations, right? So we need better models, but we're taking that direction. And my question is, how can we make an impact? Because we're clearly working on that. We're trying to, capture the most realistic scenarios, but we would like to have a better impact, and we don't see a way to engage. What should we do? Go to IETF? Should we? Because otherwise it's this constant, academics publishing papers that just remains in the academic domain and have zero impact. I would really like to find a way to have a stronger impact.
Into the 3GPP standards or into the industry, like the automotive industry, both of which are kind of very difficult.
Yeah, I know. Exactly. I mean, in any sort of, like how can academics developing and having these open communities, research thoughts and brainstorming, how can we have a bigger impact, and that does not remains, in our papers. And one more comment, always related to this TCP stuff, is recently the head of system architecture at 3GPP had some interactions with IETF to reconsider the TCP/IP stack and considering new protocols, like for example Google Quick protocol, but those are the Google people. How can we, have our say and show our results? I would like that. That's something that we would like to. But we need better models. We need better test beds. We need we need to refine all these tools that are giving us some insights about performance. So yeah, these are my thoughts about that.
Do companies care about this? Do companies care?
No, so this is no. They don't care until it hits their bottom. And so I was having a discussion with Shiv yesterday too, right? That okay, so the first thing is you have to think about, okay, what is your message that you want to convey. So I again go back to latency, right? I mean, that's nobody discusses. Industry people also, you also said, hey, there's a different part of Qualcomm that works on that. And so maybe we haven't hit that use case, right? And so what you need to think about is, okay, what are the, with our existing standards, with the 3GP work, what are the scenarios where that latency is that was my question to you a year ago. What are the situations where a millisecond latency is going to be critical, or where the current protocols will just not work, and it would hit industry in their bottom line?
Cooperative flight? Cooperative flight?
What's that?
Cooperative flight?
Cooperative flight? Well, where is it happening? Yeah, maybe. Whatever it is. I think we have a couple of
Yeah, so I had kind of more industry-related questions. So you guys have kind of got the operators to buy in 5G now. It seems like it's going to happen. So if 10 years from now you need to sell them 6G, what are the things that you have to show to them to convince them that they need to actually buy into a new environment? Is it just improving capacity by another 10 to 100x? Is it getting rid of small cells and actually making macro cells that are capable of these high capacities? Like, what kind of features do you think justify the next steps?
Actually, a big part of the deployment, if you ask operators right now, many of them don't really have a capacity issue at this point, but they think that they will have a capacity issue. So it seems that 5G will solve that. It also brings in more revenue for operators because there's all the new services that it can bring in. But a big part of it is just large operators that push forward. They want to be the first in 5G and they want to deploy it, and they know that revenue will come in. They know the demand will grow, and then at that point, the others, it's almost peer pressure. Right? You can't have one operator doing 5G and then no one else is interested, and then now other regions start coming in. Europe doesn't want to be left behind, and everyone jumps on the bandwagon, right? If you looked at the early schedules of 5G release, it was further out. It wasn't meant to be end of this year or next year, because that's really when people thought that the capacity needs would be there, and that they probably have to think about deploying 5G systems. But because of some operators pushing it earlier, now the whole world is behind, and they all want to deploy early on. So I imagine, it's hard to predict what things will be in 6G, because even it's not clear what the need is for all these in 5G. But in 6G, maybe there will be more capacity, but likely that we will need more capacity. And again, there'll be another push by operators to deploy 6G and try to get more revenue streams and think of more use cases. But it's hard to predict that at this point.
Mickey, did you wanted to say something? I forgot. Yes. Okay, I didn't see if you were raising your hand or not.
Yes, thank you. So it was related to your earlier question about does industry care about some of the simulation?
Mickey, by the way, is from InterDigital. Sorry.
And I think from our standpoint, for instance, we play in the field between academia and commercial deployments. We're smack in the middle, developing technologies. With our focus on 3GPP, for instance, we would have been extremely interested in having the NS3 network level simulator available and ready to use for instance, the NRU study item on release 16. But obviously it's not there yet. It's going to be very interesting in the future, but it could have been available for this good of mankind kind of contributions that would help develop the NRU standard in release 16. So yes, in that respect, we really care. And you know that we work with Padova, for instance, on related topics. So that's an area where we could quite well.
So why wasn't it ready? I think so. This is exactly the thing.
It's not ready for readily available for NRU, right? So NS3 has a lot of LTE functionality and capability but because it's being developed while the 3GPP release 15 was being specified, it is hard to have it available at the same time.
So is it impossible or is it a resource problem? Because if it's a resource problem, this is a perfect place where industry and academia could, and you should put your money where your mouth is and say, hey, Marco, you want to expand your team so that you have this NSC simulator ready for prime time?
Sorry, we've been, Marco can talk about this, but I mean, it is a bit of a resource issue, and we've been trying with Sumit to address exactly that.
But this is exactly the case, right, where it would be where industry, there are things in industry which they don't have the time, and that'll be a place where it could be useful, and I think it's true across the board, but people are just too busy to even think a little bit, yeah.
So, do you want to talk just quickly about discussing with Sumit and Panelists almost?
About what? Which one?
NS3 and trying to get it.
Yeah, and even more in general terms of Sumit is the maintainer NS3.
The maintainer NS3.
Yeah, which were basically.
Sumit's right.
Yeah, so we would like. I think there's a call for you guys at NSF. Basically, we're trying to find a way to get funded for growing these.
Industry should fund.
Thanks for putting me on the spot.
No, or Qualcomm. I mean, who are you? You are smack in the middle, right? You said we are smack in the middle. So you say, hey, this would be useful. You convince your industry players that, hey, this would be useful. Let's provide the money. I mean, come on, when we say government should subsidize industry, that's ludicrous. I mean, let your CEOs and CTOs take a few 10% cuts before that.
I have maybe it's not even about you guys invest, but why don't, I'm pretty sure that, I know for a fact that there's a system level simulator at Qualcomm, there's a system level simulator, I guess, at Interdigital. Why can you share the baseline? We don't want the technologies, we don't want IPs, but just the baseline, the L1 baseline for link level simulations, or the Mac. What's that?
That's exactly where you guys come in with the NS3, so accelerate the simulation, so it gets at par with us, and then we can submit it directly to 3GPP. Okay, because obviously, there's a lot of work that was put in both the NS3 simulation, network-level simulation, as well as in Interdigital's system-level simulation, right? So I think the collaboration would be extremely beneficial if somehow more resources would be thrown into the NS3 to bring it to the level that we are at. We obviously cannot disclose a lot of our internal stuff.
Yeah, no, exactly. But the baseline, there's so much baseline.
Okay, so can this be an action item for follow-up? I think this seems like this is similar to the testbed stuff where community. There is a this working group has been moving things along. You have put yourself in the middle right now as well, and so let's you place Interdigital isn't smack in the middle, so this should be an action item to kind of say, okay, what can, and you have some good questions, what can industry share, and what are your needs? How can academics help who are interested in that, and what is going to be needed to fill in those gaps that you're seeing? We need to improve models, channel models, measurements, whatever it is. This could be another action item for a plan, a community plan for a subgroup, and this could, I see it as connecting to testbed too, because measurements could go in there, obviously, and other aspects too. So I think this could be something that we could follow up on. So even though you said no to the panel, you're on now.
Actually, I'm going to, because we have about maybe 10 more minutes, so I had walked through a couple of different use cases, but I wanted to bring to this one just because maybe on Akbar's point about trying to get actionable action items out of this. So one of the use cases, of course, is on edge computing, and this is particularly relevant today with all the talk about AI. Maybe AI is in the peak of the crash and will crash. But one thing I noticed when doing a research for this panel was there's actually presentations you can look on Amazon AWS services, for example, and they have talks about 5G, what 5G will be for edge computing, but I have never seen any of them show up, not just at RCN, but pretty much any of the wireless conferences that we're going to. How do we engage with this group? Because presumably, either maybe there is no relation between 5G and edge computing and AI, or there is, but the companies that are in that space are just not talking to us. And how do we get this? Actually, this was stolen from, I forget, one of the, another cloud provider. It's not the Amazon's, but the Amazon has whole presentations which they go out and give to other AI companies on their, on the AWS services and MXNet and so on. So maybe has anybody had experience relating with Google or Facebook or AWS, and can we ever get them at an RCN? Should we get them at RCN?
I think that's actually an excellent point. I'm glad you brought it up because I think there's a lot of so machine learning is everywhere, right? So on the NSF side, we see machine learning on all the proposals, AI and whatnot, and nobody knows how it's working. And one of the places where I think from a basic science perspective, it's very useful is to understand how AI works in engineered systems. And this is a perfect example where I think, networks are going to be running a lot of data analytics on their own. It's like self-referential AI. And I think it'll be great to bring them along and maybe in traditional or Ozge has.
Actually, I do know that Qualcomm has I met them actually at NIPS, the machine learning conference. Jeff Gallagher, who we used to work with, I met at NIPS, the machine learning conference. So there is, I know, on the terminal side, looking at AI, but not in terms of necessarily in the connectivity part. I don't know.
Yeah, that's great. I mean, we do have a group that looks on the terminal side, because at least on the terminal side, for years things moved to the cloud, but now there's so much compute power on the phones, and that there are applications of AR and VR and machine learning that they has to happen with very low latency on, and can use the phone. Those groups, I can engage with those groups and see they likely do work with Google and Facebook, and
edge computing is going to be key to low latency as well.
Right. Yeah, that will be a real driver.
Yeah. So I think we need to bring that. Yes. So.
Manu?
Yeah. So one, again, the community that you're talking about and access to them. So we've had a lot of interest from our power industry consortium members, namely Intel, as well as some members in the telecom infra project. So there is a working group within that community looking specifically at AI and machine learning at the edge as it applies to telecom networks. What they're looking for is data. I think the struggle there has been access to operators and willing operators that will actually run AI and machine learning and actually provide that data. So they've come to power test beds to actually see if some of that operational data can be shared so they can run their training data sets on the back end. But again, would be happy to make that connection, and they'd be very willing to come out here and speak with us.
Yeah, there's definitely interest from the data side, like people wanting to do data analytics on the network itself, but also you look at the presentations that AWS is talking about are providing cloud computing offloading for AI. And I just don't, and they, like I said, they see 5G in their presentations, but I've never even ever seen any of these people at any of the conferences we're at.
No, I think that's an action item too for next. For your own. Have you had them at the Brooklyn one?
No, I've never seen them.
No, I think that's a good action item to get them engaged, because I think that to me, the latency is one part that gets shrugged under the rug, and this is a key enabler and AI related. So I think that would be a very good thing to bring in.
Yeah, just one comment. First of all, as Manu said, a lot of discussions, even a few days ago in San Francisco in the IEEE World Forum, talking about this and opening, because we need data to make machine learning. And the second thing I want to bring up, and it's basically an open invitation to Samsung. I was talking with some people at Samsung, and they want to do AI in NS3, basically. So this is also another unbiased comment that I make about NS3, and we'll try to bring them in specifically for this, and then we got also expand a little more on the core network and stuff.
I mean, another thing maybe for the next RCN meeting, I mean, Akbar has been asking what are the applications, and we didn't get too much response. And I think even the testbed thing, Manu's thing was, we were talking about the applications. So NSF had that on the wired side for the gigabit kind of thing, after Google Fiber and so on, NSF had the US Ignite initiative to fund applications for gigabit applications, basically for the end-to-end, but more distributed across the country, right? I mean, they're focused on how to be, and some smart cities and those kind of things. But maybe we do need to engage either the US Ignite community or have specific calls from NSF to think about applications that will drive last half gigabit, multi-gigabit wireless backbones, right?
True.
I mean, applications. And maybe we can have sessions in RCN trying to target those kinds of things in here.
I just want to, so basically the next two power platforms are actually envisioned to address that. So it's again a shameless plug for the upcoming RFP for the next two platforms. So if you are interested in building a platform that's more application industry vertical focused, because that's the feedback we are getting from industry, is to focus on applications, use cases to drive the technical requirements. And that's something that we are addressing in terms of funding the other power platform. One initiative I just want to mention, it's not a US-based one, but it's in Canada. It's called ENCOR, ENCQOR. It's a $400 million initiative between 5 telecom operator and infrastructure companies and Quebec and Ontario provinces, where they're actually doing exactly that, funding SME startups, companies to come to the table, developing a 5G network and actually having them develop applications to sort of stress test and see feasibility. So again, it's happening worldwide, and I think we want NSF to hear that too.
Well, I think that seems like another place where industry academic collaboration could be brought to the fore, because I think this is one of the goals of POWER program and also RCN to have a better collaboration with industry and academia. And personally, I think we haven't really, in RCN, we get a C for that right now. We haven't really made any progress on that. So maybe some of these things would lead to that, where industry and academics can collaborate, especially for things which are aimed at particular use cases which are of interest to industry. Okay.
All right, I think we're kind of running out of, maybe we'll just wrap it up.
We have time. I just wanted to, and we can still discuss, I wanted to, if you want to have some closing for this one, but I wanted to loop back briefly to the test bed.
Yeah, so I think maybe we'll leave time for that. So why don't we just wrap this up there? And I think so there were a couple of other things I wanted to talk about in this panel, but I think it might be better to talk about them in the context of the test bed anyway. So we could just go straight to that discussion. The one part I just wanted to, the Moonshot part, that I guess, how do we think about connectivity? And we can think about this maybe offline. Right now, we maybe just use our phone for either text or calling, but why? And what would it take for us to have this meeting virtually and not have to travel here? And part of that's a connectivity issue. And are we? Can that be a Moonshot view of this? Anyway, I'll leave it this because I think I'd rather leave time to go back into the nitty-gritty of the test bed.
Any other slides that you wanted?
No, it's fine. Yeah. Do you want?
Of interest to NSF too, because we do virtual panels. Yeah, and so we use this Blue Jeans software, and it's actually pretty effective for the most part. But I think that could be a moonshot, that how good an experience you have with a virtual augmented reality. Yeah. I understand.